Hi, everyone, and welcome to Build on Chain. Today, I'm here with Max, who's from Injective, and we're going to be talking a little bit about Injective's multi VM model. Max, do you mind just talking a little bit about your personal history with Injective and what you're going to present today?
Yeah, hello. My name is Max. I'm currently the chain team lead in Injective. My history with Injective started a long time ago. Actually, in the beginning, I was first employee, like technical guy, and I worked hard until mainnet launch for like 2.5 years. Then I left for a couple of years to just take a break, work on different projects. Then I got back, and now I would say the team at Injective is huge, stronger, and it's definitely much more fun to build when the project has such adoption. Myself, I'm a Go developer for like more than 10 years. Also, I worked with Ethereum projects a lot. So yeah, my expertise is Go, Ethereum, Cosmos, and keep doing that. So this presentation is about our newest feature that we integrating in Injective is native EVM integration, and this talk is about the features of EVM.
Okay, awesome. That sounds great. Well, why don't you throw up the presentation and we can go through it, and then I'll ask you some questions when you're done.
Awesome. Yeah, it's called Applied Multi VM at Injective because we're focusing on using the features that we built today, not in some distant future. And yeah, so this is solidified my card. So besides just leading the chain team, I'm also developing a lot of stuff and ensuring that EVM integration goes smoothly in this cycle. So what is a VM? It's a virtual machine, but in the blockchain context, it's basically runtime that executes your smart contracts on the chain. And there's like a lot of options for Web3 Builder today. If you want to build something, you have to choose your environment where your smart contracts run. So Ethereum is obvious choice, EVM, right? Custom L2 is basically a fork of Ethereum or some custom architecture that allows to run something that is not directly on Ethereum, but is rolling up on Ethereum. There's also alternative VMs like Solana VM, like Move VM with own language Move. And of course, there's like Wasm VM, allowing you to execute contracts in Rust and compile to binary. And the final one is not a quite VM, but also an option when you build something on chain is the app chain, which is most of the Cosmos chains, basically native code in Go that links, and you don't have any VM actually in the native Cosmos chain. So it's apparent that EVM is actually dominant in the crypto today, but it has many problems. So if you choose EVM, you have some kind of limitations in practice. Some of them are by design, like there's like certain execution limitations, like you have stack-based architecture. You cannot introduce a lot of variables inside the function, which you should not be caring about as a developer, but you have to. Also limitation on bytecode size, the contract size. Not deferred execution, so you have to run it externally, execute contracts. Performance penalties based on how the data is represented in memory. You're forced to use assembly if you want to optimize your code, which is not safe. So you have to balance between optimization and safety. And last thing is that, for example, UX improvement is smart accounts, which allows for gasless transactions. But the problem is that it has a lot of overhead. So yeah, I mean, this is a king of the hill, but still a lot of limitations that everyone has to work around and deal with.
Can you just going back to
Yeah,
that slide? Can you
yeah.
explain to maybe more of a layperson why some of these things are a problem? What does it mean that deferred execution is an issue? Explain what you
So
mean by
deferred
them having a
execution,
restrictive
yeah.
stacked architecture. Let's just go through a couple of them.
Of course, yeah. I think we have plenty of time, then we can chop it off. Okay, so the restrictive stack based architecture's problem is that when you write code, you have to keep the amount of variables, like function arguments it's introducing, quite low because there's a hard limit. If you introduce, for example, 20 variables in the same function and you call it, it'll say like stack is too deep.
Totally.
Basically, you have to reuse some of the variables and not, I mean, you have to reuse variables or you have to split up the functions. But I would say the problem is that in financial, we have functions, they have like 20, 30 variables. You have to do it because you have formulas. And you cannot just put 30 variables on stack in Ethereum. It's solidity is like a limitation. Next one is the contract size. It's kind of obvious. Just cannot make big contract. You have to split into small chunks. Well, this is hard coded inside Ethereum runtime, so we can change it if we have custom fork. For example, in Injective, we bumping it so our EVM has higher limit. But if you're coding for like Ethereum, which is mainstream, you still have to organize your pieces with smaller chunks of code. And last one is deferred execution. So basically, imagine a cron job, something that runs in background, for example, every block. In the Cosmos, as a contrast, in Cosmos you can have some things that running in the end block or in the beginning of the block. Basically, scheduled job that runs. It can be, for example, order book cleanup or something like that.
Totally.
For some production application that depends on state that has a lot of things going on. It's like vital to have this kind of background process that can do something like on the mass. And I mean, for example, it's not only something that runs always. You can also schedule something. For example, you can create a function that you say it should be running on every triggered by the system on every block. It's not like only system functions. It could be also contracts that users deploy that will run in background. So in Ethereum, it's not possible. You have to execute every transaction from external of the chain. You have to call it explicitly.
Okay.
Yeah.
Cool. All right. That's super helpful. So if anyone's watching, go read about some more of these issues. But these are known issues.
I think one of the most annoying for me is that the smart accounts, which is kind of abstraction for accounts that allows you to have gasless transactions or signless transactions, it has gas overhead of 100%. Like you pay twice of the gas value. Well, in practice, it means you pay instead of $1, you pay like $3, just because it's abstracted away, so it's like better UX, but you have economic penalty.
Yeah, I remember when we made Bend, which was formerly Beam, we like ran into this problem where just the amount of like overhead that you have to deal with, just in terms of call data and execution gas, is absurd. So like the call data on L2s is very, very large, so it's very expensive, and then execution on mainnet is very expensive. So that extra overhead of like the 2 or 3 times gas you have to pay becomes very significant. Yeah, that's like a huge problem for sure.
Yeah. So this is EVM, just small glance of the problems. But if you dig into every environment, you realize that every environment has own problems. Like similar to that one, I am not going to jump into everyone. Obviously, just EVM is an example of most used and the most popular. And for Cosmos, Upchain is the main problem is that you don't have VM, you don't have smart contracts. Basically, everything that developers will develop, it will be part of the actual node executing consensus. So that's a huge limitation on that part. Basically, only team that maintains the node can introduce new features without VM. So in Injective, we thought that it's a great idea to just have a multi-VM environment and basically put everything here. So we have native execution, which is part of the Cosmos node that we have. We have Cosm Wasm, which is Wasm VM running. You have Wasm contracts running on Injective. And finally, we are bringing native EVM integration. So as Solidity developer, you can also deploy Solidity-based contracts as you would on Ethereum. So basically, we just remove this limitation. You don't have to choose. You don't have to choose, and you basically have this whole environment available for you, and you can actually split your project in pieces and deploy every piece on VM or the environment you like. For example, you can have something in EVM, you can have something written in Wasm, and that allows you to avoid the limitations of each individual environment. Any questions so far?
No, this is cool.
Yeah,
it looks like if I'm understanding it, yeah, the precompile basically just takes care of it. So if you have some EVM contract and you want to perform some computation, it just dispatches like Wasm code to this precompile, which executes it and then returns like your outputs essentially, right? Like is that how I'm understanding how it would work on chain? There'd be some function that would basically like, yeah, it would dispatch the inputs with the Wasm bytecode and then produce outputs.
Yeah, so precompile is basically glue here, and for EVM we have everything wrapped inside precompile. Like it's built for finance, like Injective is built for finance. So our main focus is to have exchange wrapped into precompiles, so you can trade, put orders, positions, manage sub accounts, balances, listen for order books. Also staking, so you can do all the staking operations from within EVM as well as Cosm Wasm. And finally, obviously, the bank. There's like three major applications that are glued to EVM using the precompile. So it's basically exposed. And from the EVM side, if you deploy a smart contract, you don't even know that it's actually a native module or Wasm contract. You just have this precompile interface that you interact with from Solidity. Just a smart contract, another one.
Cool.
Yeah.
That's super sick.
Yeah. So sorry.
Oh, I just said that's super cool.
Yeah. So the idea is basically you place a heavy computational logic into Wasm. You have convenience of EVM. For example, if your protocol is EVM based, it is deployed fully on EVM, and you still can interact with all the Injective ecosystem for trading. So yeah, that's the idea. Yeah, so basically you have to decide what you need from every environment and you just use it. There's like also security benefits provided by Cosm Wasm that are not available in EVM. And in Cosm Wasm also the language is Rust, so you can use Cargo to link some libraries like zero knowledge implementations or whatever. It will work seamlessly.
Cool.
And let's not forget about IBC. So the whole chain is connected through IBC to every other like popular chain here. Like there's just examples like we have IBC bridges to Solana to Polkadot. Even there's a new IBC bridge to Ethereum itself. So IBC means that if, for example, you have a token you have to bridge, you don't have to bridge it, you can send through IBC. And that means that the chain is not only like multi-VM, but this whole thing is also multi-chain. So I will show an example later in terms of how we represent tokens so they can be seamlessly used multi-VM and multi-chain. So yeah, that's the overview. Then couple of minutes just me talking about technical features of EVM itself. So we're introducing EVM to Injective, and that's a native EVM. We basically putting a whole get here. It behaves exactly the same as normal Ethereum network would, just connected to many other things available on Injective. So features here are instant finality. As you know, Injective has block time about it's a sub-second block time. So it's have instant finality on any transaction in EVM1. You have multi VM atomicity, means that in the same transaction you can call multiple VMs. Like in VM, you can call Wasm and it gets back, again submit something to the VM side. So it's not like you have to send multiple transactions and then sync them up just within one. So if everything fails on that road, the whole thing reverts. You don't have to clean up the state. Multi VM token standard. This is going to be one of the best features that I'm going to demo. Is that we have ability to represent a single token as a single token within multiple environments. We don't have to bridge it around. Our EVM supports account abstraction, exactly the same standard as mainnet Ethereum. So every integration with bundlers, user ops, it will be all out of the box.
And that comes with no like existing like additional overhead, like you were saying.
Yeah, I mean, it comes with overhead, obviously, but sometimes it's acceptable. And we tested integration with Alchemy, light accounts. So if you can authorize using email and have a wallet on chain, it's super cool, even if it's like has some overhead.
Totally.
Yeah. And yeah, finally, the modern tooling support means that all the tooling that available for Ethereum developers now can be used to develop on Injective. Basically, you have Foundry, Forge, maybe you some hard hat from the past. You just deploy everything. You just change the endpoint from, I don't know, Sepolia or whatever, Ethereum. You just change to Injective RPC and it just deploys all the contracts normally. So modern tooling, including some production-ready debugging utilities like Tenderly, which allows you to debug execution inside the production
Tenderly is the
environment.
best. Tenderly is the best.
Yeah. That's super cool that we have this integration that actually works.
That's cool.
So last piece of this context sharing is that we introducing a multi VM token standard called MTS. It's kind of two parts here. The bank precompile allows you to send tokens and track the balance between token on Cosmos side and token like ERC20 the contract inside EVM. So you don't have to bridge anything between both environments. And we have a new ERC20 model, which can wrap any denom from Cosmos Bank into ERC20. So for example, you're receiving a token from Osmosis through IBC, which is ICS20 standard. You can wrap inside ERC20 and have it in EVM. So you don't have to maintain two copies of the same thing. Same goes for Token Factory tokens that users can create, and also Peggy, which is our own bridge for Ethereum. Yeah, so there's a huge problem usually when you have the same token, you have to represent it in many places, and wrapping and unwrapping is a very painful process. And also, it's multi-step. It's usually cost overhead. It's also just breaks UX. We just avoiding this all. We can have the same token represented in many environments at the same time.
That's super cool. And does that mean like if it's in, are you saying like within Injective in the multiple VMs you have, it is like a universal data structure and like the different VMs can interact with that data structure so that they're interacting with like the same token itself essentially is what you're saying? Or is it that like, am I understanding that right?
Yeah, exactly. So Cosmos provides bank module, which is tracking all the balances. And the implementation is basically to have this bank be source of truth for every VM, including EVM. So, I mean, for EVM, it's obviously done using some kind of hack with precompile, and I'm going to show it as part of the demo. So
that's pretty cool. It's pretty cool to think that like you have like obviously in a normal EVM, a contract owns its own storage and is only entitled to write to that storage unless it has like complex permission layer. In theory, it's kind of cool to imagine like there's the data structure that is separate from like the front end implementation. And there's some permissioning on that data to say like who can increment balances, who can send, but it can be like, but the actual logic can be implemented in multiple different VMs. That's super cool.
Precompiles are very powerful in EVM, so we're actually using them to the fullest.
That's cool.
Yep. So that's kind of it. That the context and the idea is that we basically trying to enable a new application design space where you just don't forced in a single VM. You can use whatever you like, whatever works for your product and your users, especially to develop on Injective. Like all that stuff that I just presented, it's like lives simultaneously in the same state with all the exchange related stuff that we have, so you can integrate with exchange directly from your contract. Yeah, so we have a repo with a bunch of Solidity contracts already made. Obviously, links will be shared later. But the idea is that if you look at this particular contract, which is called Bank ERC20, it's our hack that allows us to track balances between EVM space and Cosmos space. So it has a bank contract precompile. And every time we update the balance of, like when you send ERC20, it updates the balance inside EVM. It actually reflects the changes to the Cosmos side through the bank contract precompile. Yeah, so if you're developing a custom token on Injective EVM, if you run just Open Zeppelin version of ERC20, the problem is that the balances they will be tracked inside the map within EVM state only. So that's not what you should do. I think the only change that you are forced to do is to use our bank ERC20 wrapper instead of vanilla ERC20. So that's the only change you need to do to support to have this support for your ERC20 token. So for this demo, I'm going to just deploy a token and show how it works. So creating a fixed supply bank ERC20, basically creating a token with name, symbol, and initial supply. And let's see how it behaves. So I have Injective running locally, just empty, almost empty state. I added some users to, yeah, so in this demo, I'm actually using Foundry to send transactions to EVM side of things. And I also using Injective CLI to call the Injective D commands to interact with the Cosmos side of the interface, of chain interface. So this is effectively shows that you can interact with the chain from two sets of toolings. All right. So the first step, I'm gonna deploy ERC20 on chain. So for that, I'm running forge create, which is gonna compile the Solidity contract. It's gonna deploy on local URL, like this is like JSON RPC endpoint of EVM on Injective. Obviously, you have to replace this for testnet if you want to deploy on testnet, but the rest goes the same. We're just gonna deploy test meme with some initial supply. So I'm getting the contract address. This is my token, just deployed. And as I deploy it, it actually gets minted to the actual deployer. So let me check the balance of my wallet. Yeah, I need just have this variable. So this is a newly deployed address, and I'm going to query the balance. So to query the balance, I'm calling the EVM endpoint using cast. This is part of the Foundry toolkit for working with Ethereum. This is something that a normal developer will use. So I'm just calling this contract through Injective RPC endpoint. I'm calling the balance of my address and decoding the value. So basically, I got some tokens minted on EVM. So this is like a normal flow. As you just deploy a token, you minted something, you have the balance. Now, what's interesting, I'm gonna query my balance inside Cosmos now, inside Injective through CLI of Injective. And yeah, just clarification for the context who doesn't know. When I have wallet on Injective, I have the same address for Injective side and Ethereum side. It's basically the same address, just same bytes, just converted into different representations. The same entity account is shared across all the VMs as well. Yeah, so for Ethereum, I'm acquiring by Ethereum address, but for Injective, I have to query the balance by my Injective side address. So you see my balances. Some of them are like testing ones from demo state, but one is absolutely new. It has denom ERC20, and this is the address of the contract. So this is like full denom of the minted token inside EVM, but it's actually visible inside Cosmos side.
That's so sick. I feel like so how does the like hierarchy of that work when you deploy the ERC20 contract? Does it like first create an injective contract and then like deploy the EVM contract, or do you deploy the EVM contract which creates some sort of injective contract that recognizes it's an ERC20? Like how does that work? I'm very curious.
It's actually super easy. It's based on inheritance inside Solidity. So when we deploy a fixed supply bank ERC20, well, we deploy the contract for the token. It doesn't wrap vanilla ERC20. It wraps our abstract wrapper.
Oh, okay. And that like VM essentially like in that Solidity contains the instructions for like the injective.
Yeah, inside. Yeah, so basically every call that you are doing to the ERC20 that we just deployed, it actually goes through our wrapper, which inside has this precompile, hard call it, and it will
I see.
route all stuff through this precompile. You see this
That's super
bank
cool.
model interface. Yeah, so we abstracting very far away from user. So even if you are, you have production ready application, the changes that you need to make to support this is like super minimal. You just don't use the vanilla ERC20 from Open Zeppelin. You have to wrap it in additional abstract wrapper. But yeah, basically it proxies everything to the precompile, which has access to the Cosmos bank model. Yep.
That's super cool.
So that's a balance now on the bank model, and it's not only like representable; it's actually usable. I can basically just send now. Let me do this. I'm gonna create second user. I'm gonna basically send the token from the first user to the second using the Cosmos CLI only. From user 1 to user 2. And now I'm gonna have this denom specify as the value of the transfer. So you have to prepend also. Let's send some tokens here. Yeah, so I'm creating a bank send, a Cosmos bank send with amount and denom. You can see ERC20 denom. Yeah, so transaction is gone. Let me quickly query the balances of my user. So yeah, my balance in Cosmos side has been decreased because I just sent some of my tokens. But what's more important is that we also need to check the EVM side of the balances. Hold a sec. Yeah. So on EVM side, we have also this balance reflected. Yeah. So it's instant in the same transaction. You don't have to reflect things on different VMs. You just have it automatically. And last thing in this demo is that I can use this into Wasm environment as well. So I have a quick deploy Wasm thing here. I'm deploying the Cosm. Oh no. Yeah, we can just cut, the first one. but I guess Custom Blossom is not deploying today.
That's totally fine. Like, just maybe explain, because we're coming up on time. Explain maybe like what should happen here, and then like why it's relevant and important to like what Injective enables developers to do.
Yeah, I mean, it doesn't matter to actually work on the video, just the concept of it. So back to the balance update. So this balance of a token that's used inside EVM and also Cosmos native, it's also usable inside Cosmos Blossom. So for example, you can send the same token to Cosmos Blossom contract and let it manage the balance. We also have quite complicated demo in the repo. Like if someone wants to check it out, how it works with Exchange precompile, for example, you can observe this separate demo script, which will create an EVM-based contract to work with Exchange, basically deposit and withdraw funds, manage the positions and create derivative limit orders. And you can see how it works using the same tooling that normal Ethereum developer will use, basically Cast and Foundry. A token is just a demo of single balance represented in many VMs. But the general idea is that it works for everything that we have on Injective Exchange. Staking as well, so you can build your liquid staking provider on top of the Injective infrastructure. You can build it in Vostom, you can build it in Solidity, whatever you choose. Yeah, so that's the idea. And the last slide on my deck is basically resources. If somebody wants to continue exploring Injective EVM, they can follow the links on my slide. If you get slides back. Yeah, if you want, you can continue exploring this. We have EVM deployed on the testnet already. So that means, and yeah, we have permissioned currently deployment, but in a couple of days, it's going to be permissionless. That means you can deploy your own contracts and play with everything. So there's like intro in the blog post, the docs, how to get started, a faucet, so you can have funds for the gas. And last is the JSON RPC endpoint, which basically, as normal Ethereum endpoint, you can use it to send your transactions. You can add it inside MetaMask to have your balances accounts and whatever. So basically, EVM is like parallel environment to Cosmos native.
Nice. Okay, super cool. Well, I guess last question before we go. What's something you want to see built that's not currently being built on Injective?
Okay, that's tough. It's like we have a queue of projects. So basically, I mean, I see that everything that I would like to have it is in the queue. So I think the major goal for this EVM initiative is that we onboard as many projects as we can, in the first wave, so we can have a lot of things covered from early days, and remove any obstacles, because I'm pretty sure we have some issues. Something not supported, something is not working out of the box, so we have to remove those obstacles as soon as possible. So yeah, I'm not saying that it's going to be like killer app that we're missing. I'd say that overall experience of a user on Injective could be made much more easier based on EVM advanced. I think Ethereum based chains in general, Ethereum ecosystem advance a little bit more far than Cosmos ecosystem in terms of user experience. Like they introduced zero gas, zero signatures mechanics, and I think this is what we lack. I think some smart account manager that doesn't require user to know about crypto. That would be awesome. Like just imagine the user just uses as a Web2 project, but internally it's actually decentralized trading experience. Just the user doesn't need to about all that happens under the hood. So
Cool.
yeah, that's a great use case.
Okay, awesome. Well, thank you so much, Max, for joining. Super appreciate it. And if anyone wants to check out Injective, please check out these links. Thanks for tuning in.
Thanks, Christian. Yeah.